Okay, hello AP Stats students. Today I'm going to walk you through notes for 7.3. Um, this video might be in two parts. I'm not sure how long it will take. Um, and then I'm thinking I might also record a video going over some of the homework problems from the worksheet. Maybe if I don't make a video, maybe what I'll do is at least post the answers to homework 1, 2, and 3, just so you can correct your answers, and then we can go over your questions in class. That's probably what I'll do. All right, so this first page, you could pause right now and just look this over. This is a recap of everything from 7.2. So the general idea is that a sampling distribution is a distribution of a whole bunch of samples. So those are like those pictures that I have on the side of the classroom with all the dots. We took a whole bunch of samples and made a distribution. A distribution is just a picture, okay, representing all those samples. The center of our sampling distribution should be the center of the population. So if we were to do a whole bunch more computer simulations and get a whole bunch more dots on the picture that was hanging on the right, the center of that picture is probably really close to the center, if not equal to the center of the population data. So this is our formula. The mean of all of the sample proportions will equal the population proportion. Okay, then we have a formula to find the standard deviation of the sampling distribution of the sample proportions, p-hats. This formula only works as long as the population is larger than 10n. That's that first condition. That's the 10% condition. Let me grab a pen here. Okay, so this is the first condition you want to check, known as the 10% condition. If that condition holds, then you can use the standard deviation formula. The next condition is that NP and n times 1 minus p both have to be larger than 10, greater than or equal to 10. If those conditions work, then you can use z-scores. And you use z-scores with this mean and this standard deviation. Okay, so that's what we've talked about already. This is just a recap of when you're going to use proportions versus when you're going to use means. Proportions happen when you're dealing with categorical variables. So that would be like this question: what proportion of US adults have watched Survivor Guatemala? So you're going to take the amount that have watched Survivor divided by the total amount. It'll be a percent or a proportion. Or like this: what percent of the adult population attended church last week? It'll be a percent, this many out of the total. That's a proportion. So that's when you're dealing with like yes or no questions, counting the number of people who said yes, that sort of thing. You're going to be dealing with means when you have quantitative variables. So that would be income. We could poll people on their average income, their average blood pressure, the average lifetime of a car brake pad. Anytime it's quantitative, you could find the mean, and that's what we're going to deal more with today in 7.3. Here's a side-by-side comparison of what we did in 7.2 versus what's new in 7.3. So we're still going to be taking a simple random sample of size n, so the n is the sample size. And we're taking it from a very large population. Now our parameters, our population information, is a mean and a standard deviation. These are from the population. Before, we were doing a population parameter proportion. P was a proportion. Now we're going to look at means and standard deviations. Okay? We still need to check that the population is more than 10 times the sample size. That's the same. The second condition, we no longer need to check if n times p is greater than or equal to 10 or n times 1 minus p is greater than or equal to 10. We don't need to do that in this case because there's no p. It's not proportion, it's means. So what we do need to check is the sampling distribution approximately normal? Is the sampling distribution approximately normal with a mean and a standard deviation? Okay, then here's the formulas for our mean and our standard deviation. The mean of all of our sample means is the population mean. The standard deviation of all of our sample means is the population standard deviation. Okay, this is the population standard deviation divided by the square root of our sample size. So those are our two formulas we're going to be using. If all that checks out, then we're dealing with an approximately normal distribution. Here's your mean, here's your standard deviation. And then you can use z-scores. Okay, so you might want to pause and copy that page down. We're going to do examples using all this. Okay, now this page is dealing with the second condition. Let me go back here. The second condition of is our sampling distribution normal? Okay, how do we figure that out? Well, if we're drawing our sample from a normal population, then our sample should be approximately normal. So if we're drawing from a normal population, then our sample will be approximately normal. That makes sense. Well, what if our population is maybe not normal? What if we're drawing from any population? Okay, we don't know if it's normal. Well, when our sample size is large, then we can say that it's approximately normal. Sorry, I had to pause it because my son came in the room. So if it's from a normal population, then our sample should be normal. If it's from any population that we don't have any information about, then if our sample is large enough, then our sampling distribution should be normal. Well, the question then is, how large is large? If your sample size is around 30, that's considered large, and that is what the central limit theorem says. Okay, so if our sample size is 30 or more, then any population, any sampling distribution from any population, as long as your sample sizes are 30 or more, should be approximately normal. Okay, so that helps you check the second condition from the previous page. The second condition. So either you'll be told that the population is normal, or you'll have a sample size 30 or larger. If not, then it's not normal. Okay, so we're going to do a problem, all right? A company that owns and services a fleet of cars for its sales force has found that the service lifetime of disc brake pads varies from car to car according to a normal distribution. with a mean of 55,000 miles and a standard deviation of 4,500 miles. So they're giving you all that information. I'm going to write that down. The mean of our sampling means should equal the mean of the population, which is 55,000. The standard deviation of our sample means is equal to the population standard deviation divided by the square root of our sample size. The population standard deviation is 4,500. And what's our sample size? Well, it says, what is the probability that the lifetime of a brake pad on a single random car? Well, one car, that's your sample, 1. So I'm going to put a 1 in for n. So that means that our standard deviation is 4,500. Okay, so we're going to take that information, and what we want is to find the probability, the probability that the mean of our sampling distribution is more than 65,000. Well, that means that we're going to need to find a z-score. So let's go down here and calculate the z-score. So we're going to do 65,000 minus our mean of 55,000 divided by our standard deviation, which is 4,500. And when you type all that in, you're going to get 2.22. So the probability that our sample mean is greater than 65,000 would equal the probability that our z-score is greater than 2.22. Okay, and then you look up 2.22 on your z-chart, and you're going to do 1 minus that. So look up 2.22 on your z-chart, and that's 0.9868. And when you do 1 minus 0.9868, you get 0.0132. That would be the answer to the question. That would be the probability that the lifetime of a brake pad on a single random car lasts more than 65,000 miles. That's a pretty small percent. Okay. Now, I'm gonna need to record a second video because I can only record 15 minutes at a time, and I'm approaching 15 minutes. So go click on the part 2 of the 7.3 notes now. There's just a couple more examples. We're going to do 1, 2, 3 more examples. So that'll be on part 2. Okay? Click on part 2.